a fast car. I want a ticket to anywhere. Maybe we can make a deal.
Subnetting Class C. We are going to talk about Class C IP subnetting. To begin with, let's say you have a small office network that uses the 192.168.0.0/24, and your boss told you to use it to address the network. This is the network diagram of their network. The question is how many networks and hosts we get from this type of IP address. The 192.168.0.0/24. Okay, let's have a look. We all know that there are 256 actual addresses, but the 0 and 255 host addresses are not usable, giving you only 254 usable addresses. So, we've got 254 hosts in one network. Going back to their network diagram, how many networks do they need? Well, let's count it. 1, 2, 3, 4, 5. Please bear in mind that each port interface of a router is a network. Alright, so we need to break this major network, the 192.168.0.0/24, into smaller subnetworks. Let's say this may be an office from Muscat and another office across the WAN link to Salala and a WAN link from Salala to Niswa. So now we need to break it down, the one particular network, into 5 multiple networks or subnets. Let's do it.
Hi, I'm back again. So what we gonna do now is to break down this particular IP address into smaller subnets. We have 192.168.0.0/24, and we have a network requirements of 5 networks, 1, 2, 3, 4, 5, including those two WAN links considered as a networks. And down below, right here, I have binary charts. Starts from 1 to 4 up to 1 to 8. This is our network. And bits, we have bits. It starts from 0, 1, 2, 3, 4, 5 up to number 7. And the third one is to the power of 2. As you can see, any number raised to the power of 0 is equal to 1. So 2 to the power of 1 is equal to, and 2 to the power of 2 is 4, and 2 to the power of 3 is 8, and so on and so forth. And on the left hand side, we have the steps to do that, to compute how many networks we need or subnetworks for that particular IP address. It doesn't mean that we need 5 networks, we get 5 networks. How many subnetworks, meaning if we have a network requirements of 5 networks, maybe 5 networks, we cannot get exactly 5 networks, maybe 6 networks, 7 networks, or 8 networks. How many hosts? How many hosts, meaning how many hosts per subnets or per network. And finally, finding increment and network ranges. So 1 and 2, we're going to verify our answers if it's correct. Okay, let's get started. We have a 5 networks requirements. Okay, so we need 5 networks. How many bits is equivalent for 5 networks? So look for our binary chart here. This is the technique. Okay, concentrate on the network, this first line, blue blue color, on the blue color. So 1 is bigger than 5? No. 2 is bigger than 5? Of course not. 4 is bigger than 5? No. 8 is bigger than 5? Yes, it is. It's bigger than 5. So below you can see the bits, equivalent bits is 3. So 5 is equal 3 bits. Okay, and that 3 bits is equals to 8 networks, and that's the answer. Easy, huh? So we get the answer. How many networks we need? We need 5 networks, but it gives us 8 networks. It doesn't matter. Then how many hosts we need per subnets or per network? All right, so let's see our bits. We already use 3 bits, and we have only 8 bits, and we use 3 bits previously. So 8 minus 3, we get 5 bits. All right, oops, 5 bits. This is for your host. Okay, the first 3 bits is for your network. Okay, done. So sorry about that. So 5 bits, right, is equals to, look at the bits, this on red color. So where is the number 5 there? So that is number 5. Above number 5 is number 32. Oops, this is network and host. Sorry. 32 is the answer for the host. So we will write here 32 minus 2 is equal 30 usable, oops, hosts. That's it. You will ask me, I know, at the back of your head, sitting down there, where is that 2 comes from? 2 is for the network and broadcast. Okay, we don't include the network and broadcast. That's why we deduct or we minus it from 32 to get the total number of usable hosts. Let's verify first our answer. So first is how many subnetworks. We've got 3 bits, so 2 to the 3. I didn't change my color of my pen. That's okay, that's fine. 2 to the 3, look down here. 2 to the 3, where is that? 2 to the 3, 2 to the power of 3 is 8, right? Is 8 networks, so that is correct. Okay, 8 networks. And okay, I don't have space here, but we have 5 bits in our host. So 5 bits, I got 5 bits. 2 to the 5th or 2 to the power of 5 is 32. So 2 to the 5, but I'm gonna put minus there, minus 2, because for the network and broadcast. So we got the answer of 30 hosts. Okay, it's very simple. 2 to the 5th is 32. We minus 2 from it to get the total number of usable hosts. Finding increment and network ranges. So what I'm gonna do now is I will get this IP address. Okay, I'll just type this IP address 192.168.0.0 right here, 192.168.0.0. 0. But what is next? How you will know what numbers next? That is increment. We should find the increment value based on our uh, number of bits. So we need 5 networks, as you can see, the first computation here, and 5 networks is equals 3 bits. So let's see where is that 3 bits. Okay, so it's very simple. From here in our binary chart, you have to write your 3 bits: 1, 2, 3, and put the dividing line in between. Okay, so there is your 3 bits. And how do you know where is your increment? This is your increment, the last bit. So we have 32, and then it will increment 32, and you just add 32. 32 plus 32 is 64. 64 plus 32 is 96, and 96 plus 32 is, I think, okay, 6, 7, 8, 118, and again 32. Okay, 1, 2, 3, 4, 5. Okay, we'll stop there. But if we going to continue, we will reach the 8 networks. Oops, wrong computation. I'm gonna erase that. Sorry about that. All right, I think 9632, that is 128 and 160. We stop there, and let's get the range. Say 1, 2, 3, 4, 5. Okay, I'm gonna concentrate on 5 networks because we need only 5 networks, even though we get 8 networks. I'll not write the 192.168.0 because that is constant, meaning to say that is a class C IP address, and the last octet that will change. So the last octet, I will just write only the last octet here. So this is only minus. So 32 minus 1 is 31. 64 minus 1 is 63. That's how it works. Just like, what number before 96? 95, right? So just minus 1. 128 minus 1 is 127. And then 160 minus 1, you get 159. So how many networks we have now? 1, 2, 3, 4, 5. And if we're going to continue, as I said, we will reach this number of networks, which is 8 networks, until 8 networks done. So what is our network ranges in between? As our computation on number 2, we have 32 hosts, but we minus 2 because network, this is the network. I will write n, and these are the hosts. We only human, flesh and blood. That's why we make mistakes. That is a broadcast. We don't need network and broadcast. That's why we minus 2 from it, from 32, and we get only the total number of usable hosts. So you just add 1 up to 30. You just minus 1 here, minus 1, then you add 1 here, minus 1. So 32 add 1 is 33, up to minus 1 to 62. Again, you just add 1, 65 to minus 1, 90, 94. Okay, that is 94. And 97 up to 1 to 6. And last is 1 to 7. No. Whew, what is this? 1 to 9 up to 158. And there you have it. We have one network for mascot. This is for our mascot office. And second network is for Salala. Okay, that is for Salala. Yes, that is 10 hours. We've been there in Salala for 10 hours driving. All right. Next is Niswa. This is for Niswa, that particular network. And the two remaining, the network 192.168.0.96 and .128, that is one is for in between of Muscat and Salala, one links. Okay, this is, let's say, numbered. Oops, sorry. Let's number that. This is one link number 4 and one link number 5. One link number 5, that is between Salala and Niswa. All right. Oops, where is my broadcast here? This is broadcast. So the new subnet mask would be 192.168.0.0 slash what? Because this is 8.16.24. That is the original subnet mask, the default subnet mask for class C IP address. Remember, this is a class C IP address, but we subnet this one particular IP address into multiple networks. Then we have a new subnet mask of 8.16.24. Remember, we have a borrowed bits of 3 from 4th octet. So 24 plus 3 bits, 25, 26, 27. So the new subnet mask would be slash 27. So the subnet mask is 255, okay, dot 255 dot 255 dot 128 plus 64 is 192. 192 plus 32 is 224. That is the new subnet mask. Let me open a new window so you will not confuse. Okay. Okay, that's it. So we need 5 networks. Done. Okay. We get 8 networks. All right. Class. With 30 hosts per subnet or per network. And the old IP address is 192.168.0.0/24 or 255.255.255.0. Okay, that is the default IP address for Class C IP address. But we subdivide this one particular IP address into multiple networks. So now we have 8 subnetworks. So the new subnet mask would be 192.168.0.0/27 or 255.255.255.224 for each subnets or for each network. I hope you liked the video. Till next time, this is Jun Veva signing off. Adios, amigo. Cuídate.